Good morning all. Myself Ramya, working as assistant professor in the Department of ECE in Western College of Engineering and Technology, Coimbatore. I am here to discuss about image representation and description under the subject of digital image processing. This image representation and description helps you to recognize the object effectively by the computer. So, the image which has to be recognized by the computer has to be acquired first, and it has to be enhanced, restored, and it will be segmented. The segmentation output will be in the form of raw data, which is pixel. That is not understandable by the computer, so it has to be converted into the form which is understandable by the computer. That work is done by representation and description. So now we have to see about representation and description. So first, representation. The representation can be performed based on the external characteristic of the image or otherwise internal characteristic of the image. External characteristic means boundary representation. Internal characteristic means region representation. So description is nothing but based on the chosen representation. If you chose the boundary alone, you can find the length of the boundary, or you can find the number of concavities in it. Likewise, you can describe the boundary or otherwise describe the region, which helps to identify the object based on its label. So first, representation. Under the representation, you have chain code, polygonal approximation, signature. First we will see chain code. This chain code represents the boundary by means of connected sequence of straight line segments. This connected sequence of straight line segments can be numbered based on 4 connectivity or 8 connectivity, and the numbers are provided based on the direction of each segment. So for example, if it is 4 directional chain code, if the direction of the line segment is in this direction, it is 0, top 1, and this side 2 and this side 3, whereas these diagonal directions are left off. If it is 8 directional code, diagonal directions are also considered, and based on that diagonal direction, the numbering is provided. We will take one example, and this is the image where the resampling is done, and this is the final result of resampling. For this, I have to find the code. If I take 4 directional line segment, I have to consider horizontal line segment. This direction is given by 0, and again I don't have in 4 direction, I don't have diagonal direction, so I have to go in this direction and then only come down. So again 0, the downward direction is 3, and likewise again downward 3, and again I have to either come down and then reach down. So I am coming down and reaching this point. So this direction is 2, and after reaching this, what I have to do? Again I have to go in this direction and come down, and this direction go up and up, this direction here, Likewise, the direction of line segments are mentioned, and for each direction based upon this notation, you have to give the numbering 0, 0, 3, 3, 3, 3, 3, 3, 2, 2, and again 3, 2, 1, 1, 2, 1, 1, likewise. So the chain code is represented by means of the straight line segments, and depending upon the direction of the straight line segment, numbering is provided. If you use 8 directional chain code, this diagonal representation is permitted. That diagonal representation code is provided. Based upon it, the chain code is represented. But you have the problem with this chain code, that is it has long chain and it is easily disturbed by noise. For that, we have to find a solution, which is normalization. Normalization is performed by means of finding the difference. First difference. For example, this is the chain code. We have to normalize it with the first difference. So the first difference is nothing but counting the number of counterclockwise directions. For example, 1 to 0. 1 to 0 is, what we have to do is go in counterclockwise direction. 1, 2, 3. So 3 has been mentioned here. And next 0 to 1. 0 to 1 is in counterclockwise 1. and again 1 to 0. We know that it is 3, and again 0 to 3. 0 to 3 is 3. Next 3 to 3 is 0. Likewise, the first difference is obtained by means of counting the number of clockwise directions between the adjacent code. And after that, consider this code as a straight line segment and find the difference between the first and last and mention it here. First point and the starting point difference is found, that is between 1 and 0. 1, 0. Between first and last, we are finding the difference. The first one is 3 and the last one is 0. Between those, you are finding the circular clockwise shifts, and we are finding it as between 0 and 3. 0, 1, 2, 3. So you have 1, 2, 3. So 3 is mentioned in the first case. This is normalization. And the next representation than chain code is polygonal approximation. Polygonal approximation is that represent the boundary by means of polygon. It can be by minimum perimeter polygon or merging technique. Minimum perimeter polygon is that this is the boundary you are representing with the minimum perimeter and shrinking the boundary. You have to find the polygon such that the entire boundary is incorporated within your polygon. Likewise, you are incorporating, and you have to make sure that only minimum number of polygons are incorporated. After incorporating it, just relax the rubber band. Consider this as a stretched rubber band. Relax it, you will get the representation now. Right? So the polygon has to be incorporated between the inner and outer, and finally the approximation is performed. And one more form is that merging and splitting. What we are doing is first connecting the major axis. After connecting the major axis, we are finding the minor axis. Perpendicular line segments has been drawn for my minor axis, and that is considered as the corner, and we are joining it. Likewise, again after that ACDB is obtained, then I am getting one more segment here. Now join that one here, here, here. Likewise, this process can be continued until you are getting the exact representation for polygon representation to the boundary. And the last one in boundary representation is signature. Signature helps to represent the boundary in a single form. One-dimensional function. If it is a circle, we know that the radius is constant throughout the circle. So if you enlarge it, you will get a straight line. Whereas in this category, you will be getting different curvatures. This has one value and this has one value. So this is a signature. Signature is nothing but representing the shape in a one-dimensional function. So if this is the apple, if you extend it, what will happen? So start from here, you will have, start from here, I will have this one, and again one curve, again this one, then this one. So this starts from here. Okay, so just extending the two-dimensional into one-dimensional gives you the signature. And this is what representation is. Then we are going for description. So the description can be a simple description which is used to describe the boundary, which can be length. So number of pixels are counted, that gives the length. Or else you can find the diameter. The diameter is nothing but distance between the two boundary points or the major axis. Or you can find the rate of change of slope, which gives the curvature. And other than the descriptor, you have shape number. Shape number is actually found by means of the chain code. So it can be order 4. See here, it is depending upon the straight line segment 0 and downward 3, 2, 1. This is the chain code. If you take the difference between 0 to 3, 3 to 2, 2 to 1, you will get this value. And shape number is nothing but shifting this such that the minimum value comes to the first position. Here all are 3, so shifting it won't be differed. Whereas here, your minimum value comes here. So shift this, circular shift this such that 0 comes to the first position. 0, 3, 3, 0, 3, 3. 3 goes to the last category. Likewise, for various orders, the difference is calculated and shape number is obtained. Shape number is just by shifting the difference value such that the lower value comes to the first position. Various examples have been mentioned here for different orders. So, as a summary, we have seen about representation and as well as description. Under representation, we have seen polygonal approximations, signatures, chain codes. And under description, you have seen some simple descriptors and shape numbers. So, as a whole now, we have seen how the image can be represented and described such that its interpretation and recognition can be improved. These are the references which are referred. Thank you. Thank you all.